Hi friends, welcome back. In today's lab, we are going to configure HSRP with multiple VLANs. I will guide you step by step, starting from topology design, VLAN creation, then router sub-interface setup, and finally HSRP configuration with the redundancy and load balancing. By the end of this video, you will clearly understand how HSRP works in a real-world enterprise network. Friends, I kindly request you to subscribe to our channel, and if you find the videos helpful, please like and share. So let's get started. We will design the topology. Here we are going to use a 4331 router. We have a RA and RB. 2960 series switches. SA and SB. Then entry devices. PC1, PC2, PC3 and PC4. Connect all these devices. Choose copper straight through from SAG0/1 to RAG000. Then from SAG0/2 to RBG000. Then G0012 to SBG0/1. Then from RBG0/0/1 to SBG02. Then we will connect these end devices. Okay, here I just labeled all our devices, then all the ports, and we can see this PC1 will be in VLAN 10, then PC2 will be in VLAN 20, PC3 we will assign to VLAN 30, and PC4 we will assign to VLAN 40. And VLAN 10 we will use 192.168.10.0/24 network, and also here we given virtual IP 192.168.10.1. In the same way, we given for VLAN 20, VLAN 30 and VLAN 40. First of all, we will configure our switches, that is SA and SB. We will create the VLAN, then we will assign ports to the VLAN. Also, we will configure the trunk. First, we will configure this switch SA. So let me keep my topology here, left side. Enable configure terminal. I will set the host name as SA. Then now IP domain lookup. We will create the VLAN, VLAN 10. We will give name as users. Okay. VLAN 20, name as admins. Now we will go to interface FS0/1, which is connected to PC1. So this port we will assign to VLAN 10. So that already we marked in our topology here. We will give a switch port mode access, switch port access VLAN 10. Okay, right. So it's access. Okay, now we will go to interface FS0/2. So which is connected to PC2, and we need to assign to VLAN 20. Switch port mode access, switch port access VLAN 20. Now we can see two interfaces G0/1 and G0/2, which are connected to RA and RB respectively. So that should be trunking, because here we are going to configure router on a stick inter-VLAN routing. We will go to interface G0/1-2. So both should be trunking. When we give range, interface range command should be given G0/1-2. Switch port mode trunk. Switch port trunk, we will set the allowed VLAN 10,20. Copy run space start. Next we will go to SB. Enable configure terminal. We will set the host name as SB. Then now IP domain lookup. Now we'll create VLAN. We can see VLAN 30 and VLAN 40 here. VLAN 30 we will give name as users. Then VLAN 40 name as admins. Here we can see FA0/1 is connected to PC3 and we need to assign to VLAN 30, and FA0/2 connected to PC4 and we need to assign to VLAN 40. We will do that. First of all, we will go to interface FA0/1, switch port mode access, switch port access VLAN 30. Now we'll go to interface FA0/2, switch port mode access, switch port access VLAN 40. And here we can see this G0/1 is connected to RA and G0/2 is connected to RB. So it should be trunking, because as I specified, we are going to configure router on a stick inter-VLAN routing. We will go to those interface as a range G0/1-2. Switch port mode trunk. Switch port trunk allowed VLAN 30 and 30,40. Next, we will configure our router. We will configure all the interface with the IP address. So we need to create sub interfaces. First of all, we will do it on RA. No. Enable configure terminal. Hostname RA. No IP domain lookup. Next, we will configure the sub interfaces. So let me keep here so that we can see our addressing table also. Interface G0/0/0.10. So we created a sub interface for VLAN 10. Encapsulation .1Q. This is for VLAN 10. VLAN ID 10. Then we will set the IP address 192.168.10.2. Then submit to mask. Same way we will create for interface G0/0/0.20. Encapsulation .1Q VLAN ID 20. IP address 192.168.20.2, then submit to mask. We will activate this interface, that is G0/0/0. We need to activate the sub interfaces 0.10 and 0.20. For that, we need to activate the actual interface. We need to give a no shutdown. So we can see these two sub interfaces are activated. So here we configured two sub interfaces for this VLAN 10 and VLAN 20. So next we are going to configure for this VLAN 30 and VLAN 40 using this interface G0/0/1. We will create the sub interfaces. We will go to interface G0/0/1 dot 30. So this is our sub interface. Encapsulation dot 1Q. VLAN ID is 30. Then we will set the IP address 192.168.30.2. Then submit to mask. Now we will go to interface G0/0/1.40. Encapsulation dot 1Q 40. This sub interface is for a VLAN 40. We will set the IP address 192.168.40.2. Submit to mask. We will activate these sub interfaces. For that, we need to go to interface G0/0/1 and activate this physical interface. Here in RA, we configured 4 sub interfaces. So here on G0/0/0, we configured 2 sub interface, that is for VLAN 10 and VLAN 20. Then here for this interface G0/0/1, we configured 2 sub interface for VLAN 30 and VLAN 40. As per the addressing table, we used second usable IP address. So in the same way, we will configure in RB. Hostname RB. Now IP domain lookup. Now we will go to interface G0/0/0.10. We will create a sub interface for VLAN 10. Encapsulation dot 1Q 10. We will set the IP address 192.168.10.3. Then submit to mask. Next, we will go to interface G0/0/0.20. For VLAN 20. IP address 192.168.20.3. Now we will activate these two sub interfaces. So we need to go to the actual interface G0/0/0 and give no shutdown command. Now we will create sub interface for VLAN 30 and VLAN 40. Interface G0/0/1.30. Encapsulation dot 1Q30. Then we will set the IP address 192.168.30.3. Then we will go to interface G0/0/1.40. VLAN ID 40 and set the IP address 192.168.40.3. Then submit to mask. Activate the sub interfaces. We need to go to the physical interface G0/0/1 no shutdown command. Now we will verify all the configurations we have done here. Coming to our switch, enable show VLAN brief. We created VLAN 10 and 20, and here we can see FS0/1 and FS0/2 assigned to its VLAN. Show interface trunk. Okay, G0/1 and 2 are trunking. Show VLAN brief 30 and 40. Show interface trunk. G0/1 and 2 are trunking. Show IP interface brief. Here we can see we created total 4 sub interfaces. Then here on RB, perfect. Now we will configure IP address in these end devices. One 192.168.10.10. Oh, we give the correct address 192.168.10.10. Then default gateway or virtual IP, we need to set that 10.1. Then in VLAN 20, that is PC2, 192.168.20.10 gateway 20.1. Coming to PC3, 192.168.30.10 default gateway 192.168.30.1. Then PC4, 192.168.40.10 default gateway 192.168.40.1. Now we are going to configure HSRP. So initially I mentioned we are going to use load balancing also here. That means when VLAN will communicate through RA, VLAN 20 will communicate through RB. Then here this VLAN 30 will communicate through RA and VLAN 40 will communicate through RB. That means we are not going to give all the VLANs load through one router, right? So here we given VLAN 10 and VLAN 30 will communicate through RA, then VLAN 20 and 40 will go communicate through RB. So that we can see the load balancing here, partially through RA and partially through RB. Suppose if any one router goes down, automatically all VLANs will communicate through the other router which is active. Coming to the configuration in RA, we will go to interface G0/0/0.10. Okay, we should go to global configuration mode. 0.10, and here we are going to set standby 10. Okay, we are going to give the group ID as 10. We can set the version. Okay, let me put a question mark here, standby, and here we cannot see that version. Okay, we will try this version here, version 2. Perfect. Standby, we will use this group number 10. That same number will be given for VLAN 10. Then we will set the virtual IP, that is 192.168.10.1. Okay, we will set the priority standby 10 priority. Here we will give the highest priority. So he will be the active router for VLAN 10. So we'll give it 255. Then standby. Okay, we got that message. State change active. Okay. Now standby, we will give a 10 preempt. Next, we will configure for a VLAN 20. Interface G0/0/0.20. Standby version 2. Standby will give a 20 as a group number. IP, we will set the virtual address 192.168.20.1. And here we are not going to set the priority, because for VLAN 20, RA will be the standby router. So by default, the priority will be 100. We will set standby 20 preempt. Okay, preemption is enabled. In the same way, we are going to configure for this VLAN 30 and VLAN 40. So for VLAN 30, RA will be the active router, and for VLAN 40, RB will be the active router. So we'll go to interface G0/0/1.30. Standby version 2. Standby 30. We will set the virtual IP address 192.168.30.1. Standby 30. We will set the highest priority here, because RA will be the active router for this VLAN 30. Standby 30 preempt. Next, we will configure for VLAN 40. Interface G0/0/1.40. Standby version 2. Standby 40, IP 192.168.40.1. Standby 40. Okay, here we are not going to set the priority, because we will consider as the default priority, that is 100. So this RA will become the standby router for VLAN 40. Standby 40 preempt will enable preempt. In the same way, we are going to configure in RB. We will go to interface G0/0/0.10, and here in this RB will be the passive router for this VLAN 10. Standby version 2. Standby, we will use a 10. Then virtual IP 192.168.10.1. Standby 10. So here we will not set the priority. Let it be the default priority, that is 100. We will set the preempt. Next, we will create for a VLAN 20 interface G0/0/0.20. We will set the version to standby 20 IP 192.168.20.1. Standby 20. Here we will set the priority because RB should be the active router for VLAN 20. We will give the highest priority, that is 255. Standby 20 preempt. Here, whenever we configure this, we can see that this state change message we are getting. We can see this active for VLAN 20, that is RB. Next, we will configure for VLAN 30 and VLAN 40, that is interface G0/0/1. So VLAN 30, interface G0/0/1.30. This is the sub interface. So here we will set standby version 2, standby. So we'll give here 30 IP 192.168.30.1. Standby 30, and here we are not going to set the priority because we will consider as the default priority, that is 100. The reason is RB will be the passive router for VLAN 30. We will set the preempt. Now we will go to interface G0/0/1.40, standby version 2, standby 40, virtual IP is 192.168.40.1. Okay, here we need to set the priority because RB will be the active router for VLAN 40. Standby 40, priority 255. Okay. Standby 40 preempt. Yes. So we configured HSRP. Copy, run space, start. Now we need to verify our configuration, HSRP configuration. First of all, we'll go to RA. Show standby brief. And here we can see group 10 and group 30 active, and we can see group 20 and group 40, they are in standby. So this is for VLAN 10 and this is for VLAN 30. So VLAN 10 and for VLAN 30, RA will be the active router, and standby will be our RB. We can verify here. Show standby brief. So we can see for 20 and 40, RB will be the active router, and we can see standby here for VLAN 10 and VLAN 30. We can see the group number. A bit confusing, right? So just we will test the connectivity. I want to show in a simulation mode, so it will be more clear. Suppose I am going to send a message from PC1 to PC3. So how it works? So for for VLAN 10, we given RA as the active router. So this message will go through RA. So here we can see it will go to RA, but this packet will be dropped here. And this RA from here, you can see it goes to SB and then to PC3. Now PC3 should send back the acknowledgement to PC1. And for PC3, RA is the active router. We configured in that way. right? So we can see that it goes to SB, then we can see this will be dropped. So this packet will go to SA and PC1, and we can see communication successful. Now we will try another ping. For example, from VLAN 22, from PC2 to PC4. So here, RB will be the active router for PC2, for VLAN 20 and VLAN 40. We can see this packet will go to SA, and it will go through RB only because he is the active router. We can see here it is dropped. Now it goes to SB, then PC4. Then for VLAN 40, RB is the active router, so it will go through RB. Perfect. Suppose we are going to ping from PC1 to PC4. That means from VLAN 10 to VLAN 40. So here we can see it goes to SA. So for VLAN 10, RA is the active router. So it will go through RA. We can see it goes through RA to the PC4. Then for VLAN 40, RB is the active router. So it will go through RB. We can see that. So here RB, this packet will be dropped. Perfect. So we can see it goes to PC1. So that's why initially we specified we are going to do HSRP configuration with redundancy and load balancing, right? So now we are going to see the redundancy. We have here a redundant path. Suppose any one of the router is going go down. So what happens? We will see that. Let me put off any one of this router, for example, RA. Copy run space start. And I am going to put off this router. We can see this path is closed. Just coming back to real time. And we'll give some time to converge the network. Now we will go to RB. And here itself we can see the state change. RA is already down, and RA was the active router for VLAN 10 and VLAN 30. Now we can see this RB become the active router. That means for all the VLANs, for all the 4 VLANs, RB is the active router now. We'll see that. Show standby brief. So we can see all active. We will test the connectivity through simulation so that we can see how this packet traverse. Let me ping from PC1 to PC3. So this RA is already down, so it should go through RB. Perfect. We can try from PC1 to PC4. It will work. Successful. Great. We have successfully configured HSRP with multiple VLANs and tested redundancy and load balancing. So if you found this video helpful, don't forget to like, share, and subscribe to the channel for more networking labs and other technical subjects. Thank you for watching. We will meet again with the next video.